Hello and welcome to a new episode of our MBSE podcast. After a long time, again, an episode from our series MBSE Around the World. In these episodes, we talk about how MBSE is doing in a country somewhere in the world. And we have been already to several countries like Sweden, yes, Finland, China, Finland, we already have England, yes, and Spain, and maybe some more I don't remember yet. And today we visit France, and our guest is Raphael Faudou. And so, welcome, Raphael. It's great having you here in our show. And well, you know yourself best, so please introduce yourself.
Yeah, thank you, Tim. Thank you, Christian, for organizing this podcast series, great series, and for inviting me today to talk about what happens in France about system engineering and MBSE. So I started my career as software engineer in 1993, so almost 30 years now. and I started in Paris because there was not so much work in Toulouse because I had my computer and science diploma, engineer diploma in Toulouse high school. I started on software development and project manager. In 2001, I had the opportunity to go back to Toulouse, and 1 year after to join Atos, which is a big IT services company. And Atos has just been awarded at this moment by Airbus on the aircraft A380 to develop embedded software using UML. It was the first time UML was used in Airbus. It was quite a good challenge. I like it. But after a few years, there was a more interesting initiative started by Airbus also and other companies. That was the Topcase modeling platform. Topcase meaning toolkit in open source for critical application and embedded system development. And the idea was to develop a platform using models to ease to support the system engineering activity at the design office. So it was quite a challenge because the Atos was in charge of different parts, and I was in charge with my team to develop a SysML editor. It was the first SysML editor in 2006, open source SysML editor based on Eclipse, yes. And was a challenge because I didn't know system engineering. So I had to learn a lot about it in order to understand how this modeling tool, this editor, would be used by a system engineer at Airbus and other companies of the supply chain like Safran, Thales, and others. So a very interesting project, and I appreciated it so much that I wanted to focus a lot on system engineering activities. And after some years, I had to conclude that Atos was probably not the best place to do system engineering because it's a software-oriented company. And finally, I decided to leave Atos and to start and found my own company, Samares Engineering. So it was in 2013, so almost 10 years ago. So I started Samares, and at Samares started alone. Then we were 2 and 4, 5, and so on. And now we are almost 13. We are 13. And every day at Samares, we use modeling tools and modeling, and we perform model, and we try to help the industry switching from the document-based approach to the modeling-based approach, MBSE, in fact. This is really our core activity, our core expertise, and we are really happy with that because there's a lot of challenge in this MBSE journey, and we are just at the beginning.
Okay, great. And also a warm welcome from my side, and it's an impressive MBSE or SE story. So, yeah, we're visiting France, and maybe we shall give our listeners some overview over the industries, the main industries of France, and of sure you know where systems engineering and model-based systems engineering is already used.
Yes. Where SE and MBSE is used in France. Okay. For that, probably that we need to distinguish a little bit the different industries because The story is a little bit different if you are in aerospace and defense or in other industries. So I will start with aerospace, because there's something really special in aeronautics is, at least for civil aircraft, is the certification. The certification, obviously, you know that the flight you will not be authorized to fly your aircraft if you don't have the certification at the end. And because of that, there are a lot of guidelines that system engineering of aerospace industry have to follow. I can mention the ARP 4754 for the development. I can mention the ARP 4761 for the safety assessment. And with those two parts, this is really prescriptive in the sense that if you want to reach the certification, it's recommended that you follow those guidelines. And those guidelines, they will tell you that you have to use function, that you have to allocate your function to system or to item, software or hardware item, that you have to manage and do engineering of your requirements from one level to another, to the level down, and use traceability, at least for the most critical systems. So because of that, we can see that the aerospace industry, they are used to system engineering practice for a long time. So finally, it's not surprising that all the supply chain coming attached to a company like Airbus, they are used to those system engineering practice for some times, and they widespread those practice into their companies. So this is the first important thing for aeronautics. Then if we look at MBSE, the second part of the question, so MBSE, Airbus has seen very early that there could be good benefit in using MBSE in order to limit the design and verification efforts with better consistency, better completeness, and also trying to detect errors or issue or misunderstanding in the requirement very early in the life cycle. This is one of the key benefits that Airbus mentioned in their first experiments on using MBSE 15 years ago. So that gives good explanation why system engineering and MBSE is strongly deployed in aeronautic industry. And if we focus on space, obviously we all know the big projects developed by the space industry with going to the moon and things like that. So NASA has played a great role on that. And they have learned from their failure, and they have developed the NASA System Engineering Handbook, which is very interesting guide. So in Europe, there were a lot of efforts to try to define some standard at European level. And I can mention the ECSS, which is the European Cooperation for Space Standardization, on which France has played a great role with the Space French Agency, the CNES, but also the big companies acting as prime in those big projects. I can mention Airbus Defence and Space, that was previously named Astrium, and also Thales, Alenia Space, two major actors in France on that. What is very interesting for space is that at space, you don't really have the certification. Okay, for a satellite, there's no risk of someone being killed, so it's not as prescriptive as it is in the aeronautics. You have more freedom, you have tailoring, but something is really important is that in space for a satellite, you will not maintain it. Okay, so it's really key that you can deliver your system with the right performance, the right system with the right performance at the first time. And for that, you really need to have strong guidance, to have a common alignment of everyone on the best practices, because first time means that you cannot fail. And so the good news is that if you think about the way industry is organized in France, Airbus and Thales both are also actors of the aerospace, of the aeronautics, which means that all the good practice coming from the aeronautics have been widespread, have been declined, have been refined and could spread on the space industry for those two actors. Which means that finally in the space industry we can say that there are good practice on system engineering, and MBSE is also seen as a strong enabler to limit the efforts in verification and better improvement of the requirements.
So it seems that that Thales and Airbus are so the main companies in France.
They are very
using
big
MBSE?
companies. Yes,
Yeah.
absolutely, and Safran also, Safran. But yes, those two actors, because they are involved in both aircraft and space, it was a very how can I say that? It gives you some. There's the internal mobility between people. I know a lot of engineers in Toulouse who have switched from aircraft to space or space to aircraft, and that's very important for a company to have some oxygen coming from the guys coming from over industry, over sectors.
Yeah.
It's really important. It gives you new practice, new way of working, innovation, and at the end you are stronger with that. So that's important. I can also mention the defense. Defense is a little bit special in the sense that there's the NATO framework. I think has played a big role because it gives you some framework, some layered framework in order to define your concept of operation, your capabilities, your operational scenario, the resource, the architecture. So all those things are given as a standard, as a grid, and it's easier for companies to follow a grid. Probably we will come later on that, but it's key to have guidance in your modeling tool. So with the NATO framework, we can say that defense has adopted some system engineering practice, at least for the problem space, the mission level, the system of system engineering, and also has started with using models through the NATO framework. And here again, we find Thales. Thales, which is a strong actor in France on the defense, and because of the space and the aeronautics, they were able to push also the modeling approach into the defense sector. If we look at over industry, and I will not I will not talk about whole industry, but what I can say is that it's more recent, their involvement in system engineering. I would say something like 15 years ago, 10 to 15 years ago, automotive, energy, and so on. All of them have now started to use system engineering practice because they know it's important to have requirement engineering, architecture, design, verification, validation, and so on. And almost all of them have now started to evaluate and to use MBSE also in France. Maybe the only one I was not able to meet is civil engineering, but it may change because you know that there's the BIM standard, which is the building information model, and probably I expect to see some company from the civil engineering at AFIS, the French INCOSE chapter, very soon.
Oh, that's interesting. I'm currently also in contact with companies from the civil engineering, and they're interested in BIM. So, and they think MBSE could be a good counterpart to BIM.
Certainly. Probably with some adaptation, because I'm not sure it's developing a building, developing a system. Yes, there are similarities, but maybe there's some difference also. We will see.
But what they achieved, instead of the traditional MBSE guys, they have a working exchange format for the models.
Yes, that's true.
That's very, very interesting how they solved this issue.
Yes, that's one of the challenge of MBSE also today.
So then the situation in France is quite similar to other countries. No? So the traditional systems engineering domains, like aeronautics, defense, and space are dominating the system engineering market. But compared to other countries, what's probably more special to France is that you have these huge companies there, Airbus and Thales and so on.
Yes, true. With a big supply chain, and you think about Safran and Thales, there are more employees than in Airbus, so those are big
Oh,
actors.
really?
Yes,
Wow.
really, really. So
So,
it's not. It's more a partner than a supplier. It's both probably, but you need to be able to discuss with them and understand each other. That's why, for instance, an Airbus will not impose Thales to work with their tool, their Cameo System Modeler with SysML. No, Thales has developed Capella. Before it was called
yeah.
Capella, it was Melody Advanced. And after they have opened it as open source, as Capella, and Thales will use Capella. There's the challenge here to be able to interoperate between two actors. Or for some other topics, Airbus is able to impose to say, you will use our tools, but not with actors like Thales or Safran.
Yeah. But was there or is there a relationship between Topcase and Capella? So both tools were developed in France, and both tools are Eclipse-based modeling tools. So is there a
Yeah,
relationship? Or
there's some
yeah?
relationship in the sense that Thales was part of the Topcase initiative. They have some funding from the French government,
Okay.
and they use it to learn about Eclipse and to go further on that. At this stage, it was not Capella. It was more internal to their engineering department. But it's probably at this moment, at this period, that they learn a lot about Eclipse development plugins internally and with the support of OBO. OBO, there was an important supplier for Thales to develop that will become after the Capella platform. Yeah.
Oh, okay, interesting. Okay. So, well, I assume that you have a huge demand for systems engineers then in those companies, in particular model-based systems engineering.
Yes.
Uh, how is the situation in France, so in the job market? Are there enough systems engineers there, or?
For the job market, you mean?
Yeah.
Yeah, for the job market, well, it's, I would say it's a little bit crazy, but let's start maybe with system engineering. System engineering, now hold the company, it's clear for everyone that it's a core competency, and it's now considered as a real discipline. So it's not you will do some system engineering activity in addition to another job, another position. No. You really want to hire people to be systems engineers. And more and more, I see companies who would like to hire system engineers, but there's not so many available on the market. The experts will not change, or for very high salary. And the situation is really worse if you think about MBSE. With the MBSE is a buzzy word, probably it's same in Germany. I would say that within the next 2 years, if I remember 4 years ago, Samares Engineering specialized on MBSE, we were at the top ranking of Google. And I didn't do anything to reference as a reference man. Nothing. We just use MBSE. We talk about MBSE. We were the first batch of Google. No, I don't know where we are. Probably very far because I don't work on it, especially. But what is really sure is that on LinkedIn, a lot of people I know have no MBSE in their title. Within the 2 previous years, things have changed their title, their position to be in the MBSE world because it's really trendy. But so the problem is that today it's very difficult to find an MBSE engineer on the market, and at least when there's some young engineer who has maybe 2 years of practice of modeling, they will ask an incredible salary, and you can be sure that within 2 weeks, they will have 10 job proposals. Okay. So the market is crazy today, at least in France. And we need to find other options in order to have our MBSE engineers. I mean, it's too difficult to find experimented MBSE engineers. So our strategy at Samares Engineering today is really to train them. We are okay to train junior, but also senior, not involved in MBSE today, but will become expert in MBSE tomorrow because we will train them internally. It's too difficult to find them on the market today.
Oh, that's very interesting. The French border is not far away from my place. So
Yeah. You're welcome. You're welcome. So many requests to handle. So yeah, there's
yeah.
a great potential. Yeah.
Yeah, coming back to those people who are working on MBSE or have MBSE on the title, are they somehow involved in AFIS or are they certified or do they have just the title in the job description?
Yeah. Good point. Good point. Yes, in AFIS. So AFIS is the French INCOSE chapter. That I think that has been founded something like 20 years ago by Thales. You know what Thales was a
Yeah.
great actor of the French industry and system engineering. And in AFIS, there are more and more system engineering professionals. So yes, it's really recommended that when you have system engineering skills and experience, that you reach AFIS and you subscribe to AFIS, because AFIS is a wonderful place where you can meet different companies from different industries. And what I said a few minutes ago about the oxygen that you get from internal transition and mobility, you will get with AFIS. I remember that I could discuss with people from several different industries, and they were different background, different culture, different way of working. And at the end, when you have spent 6 months on a specific working group and topic, you have learned a lot, because you were able to discuss in a practical way, not the theory, not the standard, not whatever, but people working in the everyday life. And from each other, we learned a lot. It was really beneficial for everyone. So I would strongly suggest, if there are people who listen to us, to join AFIS, subscribe to the working group, because it's a key place to learn a lot. And at AFIS, not necessarily AFIS, but in France, I would say that today we have, at the end of last year, in December, we had 177 system engineering professionals certified from the INCOSE, including around 100 ASEP knowledge, the first step, I would say, something like 70 CSEP confirmed, certified, and 6 to 7 ESEP,
Wow.
where you need 20 years experience.
Yeah.
It's roughly, France is the third rank, except the USA, in Europe, behind the UK and Germany. Good point for Germany.
By the way, do you have a French certification program, or do they do this in English?
It's in English today. It's in English, and the good thing is that more and more the engineering school, they prepare their students for this exam, and I think it's very good thing.
Wow.
Yes, I can think about Supero, ISAE Supero, which is a high school, I would say, dedicated to aerospace, but not only. And student can register to preparation of the ESEP certification, and they have something like 30 hours or more with some tutor to learn that and to prepare to understand the system engineering handbook and so on. So good, that's very good.
Cool.
And I would say that it's important to do that, because the industry is also now aware of those system engineering certification in COSI, and they request more and more to get it. So you cannot really find a mandatory requirement about the certification in France, because I think it would not be legal. It would be kind of discrimination. But it's more and more that you find the nice to have in COSI certification. So today, as a company, if you want to be competitive on this market, you need to have a skill center and to be able to exhibit a pool of certified engineers. That's our case in Samares Engineering. And for me, it was really important at the beginning we use this certification not only to say, okay, there's a label and this kind of things. No. the motivation was a little bit different. It was, okay, let's learn, let's go to the ASEP in order, I wanted to be sure that my colleagues, we are all aligned on the same vocabulary.
Yeah.
Because if you think about it, system engineering, there's a core vocabulary. And I'm sure you have the same experience than me, that when you discuss about verification and validation, if you go to aeronautics or automotive industry, probably people will give you different definition on that. And what is a system requirement? What is a stakeholder requirement? Is it the same thing or not? Wow, this kind of things. So for me, it's important to have the ISEP, not just to put it on your CV, but it will demonstrate that you have the right foundation. And if you have the right foundation, at Samares, we work for different customers for different industry, automotive, energy, aeronautics, space, and so on. And as there are different culture, different way of working, the common thing is not the English. Now is the system engineering common vocabulary concept that we have learned in the system engineering handbook, and now we have the same vocabulary. We are more efficient on the paperboard to discuss. So for me, it's really important, and it's not just my personal opinion. I see more and more industrial company going that way and pushing their employee to go this INCOSE certification.
A good test question is if they understood the vocabulary is to ask the difference between concept of operations, operation of concepts, ConOps and OpsCon.
Exactly.
Sometimes
a little bit tricky. That's why it's
but
really
if people
important.
can answer that, then it's...
Yeah, we can answer that, yes, at enterprise level or more at the operational of a system. Yes, but but something interesting I would like to come back on that, because initially at Samares we delivered MBSE trainings, starting MBSE, because a lot of people wanted to go to MBSE, and realized after some time that, wow, the guys, they want to go to MBSE, but they are not so comfortable with SE, and that's a big problem. When it's Airbus, it's okay, they know SE. But when there are new company going to MBSE directly without strong foundation on SE, it's too much, because you have to learn a new language, new processes, new way of working, new tool. Wow, so many change. And finally, they struggle at the end. So now what we say, okay, let's start with system engineering fundamental one day. We see the concept of everything, life cycle stage, life cycle concept, ConOps, MOE, whatever. Okay, it's a lot of theory. We try to practice to illustrate, but after that, you can build modeling on top of SE. And MBSE is what? Is to support SE. People forget about that.
And so finding good systems engineering is one challenge. Then what you mentioned now is a challenge. Are there any other typical challenges in the context of MBSE that you can see in the company's trends?
Yeah, there's a lot of challenge. I'm not sure that they are all specific to France, but there are some specific challenge. So if we think about the typical challenge that is not new, is to be able to find the right, accurate modeling tool. Every company that starts in MBSE, they say, which modeling tool shall I take? Which language? Capella or SysML tool? Okay, that's the difficult point. So, but things have changed, and because before, when I participated to this kind of survey or assessment of the tool and whatever, the main criteria were almost the same: usability of the tool, functionalities, the cost, acquisition and maintenance, obviously. And maybe sometime try to evaluate a little bit the learning curve. With those variation of that, there was the evaluation and some selection. But now things have changed recently, because at least in France, there's some impact, some relation, some influence of the PLM solution, the product lifecycle management solution. More and more, the company, they choose at the corporate level their PLM solution. And there's something that happened a few years ago when Dassault Systèmes has acquired the Nomagic company. They have acquired their no magic tool, Katia Magic now. And because of that, there's some influence. Because if you think, for instance, let's assume that you're in a company that has just selected 3D experience. And as Dassault has announced that they are currently integrating the Cameo System Modeler Katia Magic tool in their 3D experience, you know that within 6 months to 1 year, you will be able to do SysML and connect your SysML model and relate your SysML model to Katia and to the rest of the and to the configure and to Enovia and to the PLM solution. So at some level of the management, at top level, I would say, well, you cannot forget about you naturally you think about this integration. You know that it's really costly to build integration, gateway, and so on. Mm-hmm. And probably there's some influence of the PLM selection to the choice of the modeling tool. So we see that some company who have selected, and some are just on the evaluation, but when they have selected officially 3D experience, very often they will select Cameo System Modeler as their SysML solution. Mm-hmm. But it's true in the other way. In the opposite, if you have, for instance, Siemens, if you have selected Siemens Teamcenter as PLM mm-hmm. solution, today, probably you would prefer starting with or using Capella, because you know that Capella, which is rebranded by Siemens as SMW for System Modeling Workbench, it is now partially integrated with Teamcenter. So it's good to know that. Except maybe in the future, perhaps if you want to wait a little bit, then you may use Rhapsody in the future, because you know that IBM, or maybe you don't know, but IBM and Siemens have announced some collaboration in order to deliver integration of their new IBM Rhapsody with Teamcenter. So it changed a little bit the game. Maybe it's about SysML v2, I don't know. And finally, the ideal solution would be that you have no PLM selected, then you are completely free. But I must say that in France, it's less and less the case. Most of the large companies, they have a PLM now. Mm-hmm. Okay. So that's the first challenge, I would say, choose the modeling tool. The second challenge I get in mind is that it's still difficult to know which concept you're going to use when what are the stop criteria when you do a diagram, where should I stop, what is the granularity level, which concept of the tool palette should I use, or whatever. So in this area, clearly Capella brings some advantage, at least at the beginning, because there's the Arcadia method, which is embedded into the tool, and that provides a lot of guidance. So when you don't know anything, you would like to start with MBSE, with Arcadia, you will get both the processes, I would say, aligned on the ISO 1588, probably the version 2008, not the last one, but not so far. And you will get some process, some transition, and the modeling concept. So you just follow the wizard, and you are able to do some MBSE, at least at the beginning. After sometimes, maybe you will want to perhaps change a little bit the approach, or not to follow completely Arcadia. Then it's more difficult. But for the beginning, you go fast with using Capella. If you choose SysML on the other way, wow, you just get a notation, no method. The good thing is that at least there are a lot of very good SysML methods all around the world. We can mention OSE, SysMod, FAS. We get the author there. excellent work, and with some very good book on that. And more recently from Dassault, the Magic Grid V1 and V2. Which is very, very active. Dassault, the guy from Dassault, Este, Aurelius, and maybe others. And recently they have added some complement on the VNV support of the Magic Grid, which is very, very cool. So now there's some guidance coming with this those different methods. The problem you still get is to choose the right method for you. to learn it because it's not fully embedded into the tool. So there's still more effort than using directly Capella, I would say. But things are changing more and more.
Yeah.
That's probably the second challenge. I get in mind another challenge, which is more about technical things, about product line engineering. More and more, I see companies who would like to use both MBSE and product line engineering. So you need to combine. I think, Tim, you have developed Vamos, things like that, to address part of it. But if you want to go further and get some automation with a big product line and so on, probably you need additional modeling to extract the feature, to extract the variability into some feature model using MBPLE or pure variant things or gears or whatever. And the challenge is to relate finally your variability with your architecture, your variability with your requirement, but you also want to relate your requirement and your architecture with traceability. So finally, you see that there's a kind of infernal triangle where it's not easy to get the consistency. That's kind of challenge that is going to happen more and more today in France, but probably at other countries also.
And I think that's everywhere. No, that's one of the next big things, I think, this model-based product line engineering.
Exactly.
And typically, now, if we do a project or create a model for a system, we only focus on one single system, but the default is that we have a product line. Variability is always there, so that should be the default. But all methods focus on a single system. So I think it's time for a change there.
Absolutely. And today the situation is that there's not so much innovating new program with everything changed. So we are more in increment. If you think about aircraft with the 320, 380, 340, 350, globally now you have a new extended range or things like that, but those are increments, some change here and there before the next generation with hydrogen, probably. But except that, those are increment, variation, and finally, you really need to have product line engineering. So you need MBSE, you need product line engineering, and you need to be comfortable with mixing both, which come from different silo at the beginning, not silo, but different ways at the beginning. So now it's key to be able to mix, to combine together. And there's not so much expertise on that today. That's technical things. And finally, I would like to mention something really important more and more, which is the digital continuity. Digital continuity, we hear about it almost every day. What does it mean? It means that now the industry has understood that MBSE, okay, it's cool, it's interesting in order to better formalize the architecture and the requirement, but they understand that it should not be limited just to the development and the descending part of the V-cycle. It should also be used for the verification, for the validation, for the CONOPS, as you said, for the early validation through simulation. But not just the development also. So we see more and more initiative to use the MBSE technique on the manufacturing, for instance. Because if you think about it, what is a factory? A factory can be considered as a system. It's an industrial system. And probably there's some difference with a product system. Because, for instance, for what I can see, in a factory, you are more interested in calculating the rate, the production rate, than trying to do a functional architecture of your factory. Functional architecture, okay, it's not so complex, but the rate with the supply chain and all the material coming at various rate, whoa, with people and operator and maybe robots cooperating, wow, that's a big challenge. So MBSE is probably a good opportunity, but I'm quite sure that it will not be the same recipe that we have used for product that we should use for this industrial system. So you see that MBSE is now expanding beyond the development stage, going to manufacturing. And if you continue, you will find also modeling, also, I'm not sure it's MBSE, for the operation. Why for operation? Because you have the digital twin. Every company would like to be able to get the data, to anticipate some dysfunctional scenario, introduce them virtually before it happens, to see what happens in operation. So in that case, you need to have a quite detailed model that really reflects the situation in operation. And finally, you need to have a wide range of models with different abstraction level, different granularity of level with different details, starting from the concept stage to the development stage to the manufacturing, production, and also operational maintenance also, and probably retirement. If we think about nuclear plants in France, there's a huge market about decommissioning and retirement disposal. So it's key to have also modeling to support you in this journey. So this is the digital continuity between the stage, but you also have the digital continuity in the supply chain. Because when you have developed a model for the aircraft or for a control system, you also want to refine it at a lower level with your partners or supplier, with Thales, with Safran, Latécoère, and others. So how do you ensure that the model that will be built by your supplier, you can integrate them? Because you would like to integrate virtually. You don't want to continue with the textual requirement. It will be very a pity if everyone works with model, but you communicate through requirement, textual requirement. Wow. And currently it's the situation. So then we get two things to address. First challenge is to ensure interoperability of the model themselves when you have different tools, like some using Capella, others using Cameo. Second challenge that will come is that you need to have the contract management into the loop, because if you want to send a model that is a specification model, you need to be sure that it can be considered as a specification by the purchase department. So what does it mean, a specification model? RFP with requirements, textual requirement, everyone knows now. But what does mean a specification model? How do you know where are the requirements in your model? You see very good challenge for industry and tool vendors for the next years.
All right, so time flies. We have time for one more question, and
yes.
Our listeners should take the time to hit the subscribe button, subscribe to this YouTube channel or to your Spotify list where you're listening to us. Wherever you are, don't forget to hit the subscribe button to not miss out any new episode. So we have tons of more questions for you, Raphael. But one question I have, which is again SysML related, because I'm a big fan of SysML. We already heard from you that Cameo Systems Modeler is very present, that of course Capella is very present because it's also a French thing. Is there any space for the others?
Limited, very limited. No, clearly for the SysML market, I would say that Magic Draw Cameo System Modeler definitely is the first one in France, at least, because clearly the usability is very, very good, and the tool has been developed not by software specialists, but by people who go to their customers, especially NASA, JPL, Boeing, and so over, and Airbus. And Cameo has been developed with a lot of cool feature, very useful for system engineers. I can think about, for instance, the mass breakdown that you can define in one click, the roll-up pattern, this kind of things, the drag and drop. Excellent. So in terms of usability, clearly it's the top with Enterprise Architect from Spark, which is very good. But there's a difference. The main difference I see is that with Cameo, there's a very strong compliance with the SysML specification, which is not really the case with Enterprise Architect, where you can have your parts not aligned with the blocks. I will not detail there, but the SysML compliance is not perfect in Spark EA today. And if you want to benefit from your model at some point, and you would like maybe to use, for instance, the simulation to perform some kind of early validation where you invite your customer and user to look at the behavior and check if it's the expected behavior for your personal concept, for instance, you would like to be sure that if it simulates, it's really because the model is okay, or if it doesn't simulate, it is because you get a problem in your model. You don't want to take 2 hours looking at, is my tool, because maybe the problem comes from the simulation engine, from the tool. No. You want to trust the tool, and to be able to trust the tool, you need to be sure that it complies with the specification, which is the case with Cameo. So Cameo is really number one, clearly, for SysML. Then you get EA. I would like to mention Rhapsody and Integrity Modeler that have been very good tool, but 10 years ago, they were the first tool because they supported simulation. That was very new for a system engineer and very cool. But IBM and PTC have, in my opinion, have failed in renew or adapting their tool for usability and for ergonomy. That's really poor ergonomy. You do some drag and drop, you can have things that are this kind of nonsense. And so today they are not in the market. Maybe tomorrow with SysML v2 we change something, but today, so I know company who have spent maybe hundreds of thousands of dollars with IBM consultancy in order to customize their tool. For some features that are there almost out of the box in Magic Draw Cameo today. So, and if you think about the other tools, I would say that Modelio Soft with Modelio as some part of the market for education.
And it's a French company, right?
Modelio? Yes, French company.
Modelio Soft?
Yeah,
right.
absolutely.
Again, French.
Yes, Soft Team before it was.
Soft, right.
Yeah, exactly. Same guys, same company. And so in education, they have some partnership, but except that their SysML tool is not so impressive, and I could not see any use of it serious in big, large industrial company. And we can think about Papyrus, which is Eclipse-based open source tool, mainly used for academics, for research. So it's cool if you want to use it alone for a research activity because it's free. But there's not so much good support on collaborative approach, and clearly the usability is not there. So you will not use it seriously in a personal deployment in industry.
You are the capital of Eclipse-based modeling tools, right? So Topcase and Papyrus and Capella.
Yeah.
So.
Yeah. Yes, Papyrus was developed at the same time of Topcase. It was concurrent development funded twice by the French government. Wow. So finally, they asked Airbus and the CA, the French nuclear agency, to join their efforts, and there was only the Papyrus at the end.
Okay.
Yeah. So for this market, Cameo is really the first one. And because of what I've said with the 3D experience, there are several companies who wonder whether they should choose between Capella or Cameo, because if they select 3D experience, then Cameo will be easier to integrate because it will be integrated natively. So, okay, I don't come back on that point, but it has some influence clearly today.
Okay. So I think we're running out of time. So so let's close this very interesting episode here. So thank you very much, Raphael, that you were here in our show. It was very great to have you here. Very interesting.
Pleasure. Thank you. As you can see, I'm passionate, so I can speak 2 hours, no problem.
Yes, exactly. So then, look forward. Our next episode is about MBSE and artificial intelligence. Interesting topic. And we will talk about that together with Alessandro. His full name is Migliaccio. I think I spelled it correctly. He wrote a book about MBSE and neural networks, and he will be our guest in next month, May the 15th. So that's the next episode. And we will announce it soon officially on our website and LinkedIn and so forth. Yeah, and though finally, as usual, do not forget,
trust us, we are systems engineers. Goodbye.
Thank you.
Bye-bye.
Bye-bye.